So now the part we were all waiting for, that how do you find the magnitude of resultant if the magnitude of two vectors are given? So again, let's start with our routine that we take two vectors. This is the vector A. Let's just change it for a while today. Let's say it's P. And this is the vector Q. The lines are quite straight today, you see. Okay. And you'll notice that all of them started from a single point, so that their initial points are the same. So we're doing it for a purpose. So you would see that clearly. Because we are finding out the angle between the vectors, and in case of angle between the vectors, you have to either put the heads together or the tails together. So I put the tails together here so that I can find the angle between them, which is let's say phi. It doesn't look good in mine, so let's call it alpha. So yeah, it's alpha. And let's find out the resultant here. So to find out the resultant, we can just shift the Q right over here. So let's shift the Q right over there. This is the Q vector now. And the resultant will clearly be from here to there. So that's the resultant, let's say R. Okay, that's the resultant. And we can also do this. We can also put the P right up across the board over here. Then you will see a magic. What the magic is that you see that this Q right here is parallel to that Q, and this P right here is parallel to the P downwards. So that means that this is a parallelogram. And when we add two vectors, okay, in which the tail of the or the head of the vectors are at a singular point, let's say O, then the resultant will be the diagonal that goes from the Q and the P to the other side. Let's say this side is A. Diagonal OA is the resultant vector. So let's suppose you are given a figure just like this in futures. Let's say we had starting point of A right over there, and also the starting point of B, it started right over here. So what we could do in this particular picture is, you can think of it as two sides of a parallelogram. You can draw another A right over here and draw another B right over here, and just go right through, just like cutting the diagonal, and you'll get the resultant vector. And this is very logical right over here. You can clearly see why this happens, because we also can see that the initial point of the first vector and the final point of the second vector is matched, so it is true. And to find the magnitude resultant, we need to do some tweaks to this figure particularly. And just so you know, this is the parallelogram law you've all been waiting for. I just don't like this law, but I like the concept of this law. I don't call it parallelogram law. I just enjoy the parallelogram law. So now what I would do is I would extend this part. So let's just dot it. Just extend this part and extend this part right around here, so that it creates a 90-degree angle. Okay, so listen carefully, see carefully. This A, let's say this is the B and this is the C. This AB is parallel to this part, the Q vector. So, and this is also the intersector. The Q is the intersector of the two parallel lines. That means this angle right here and this angle right here must be equal. So this is also alpha. Right. Now we look at where we can find the resultant R. So a trick right this here, that we can find the resultant R in this whole triangle. So we have to work with the whole triangle to get to the equation. So now in triangle AOC, we can clearly see the OA is the this whole triangle is a right angle triangle, right? And OA square is the hypotenuse, and the hypotenuse will be equal to the base, which is the the OC squared, plus the height, or the perpendicular, which is, or you can say the opposite, which is the AC, plus AC squared. Now OC, what is OC? OC is the full part right over here, but we can clearly divide it into two parts. We can clearly divide it into two parts of OB plus BC. So we can clearly write that it is OB plus BC whole squared plus AC squared, and let's just complete the formula right over here, that A squared plus 2 AB plus B squared plus AC squared, just right there. So this is, my boy, equation number 1. And we will now look at another triangle. So what triangle are we looking at right now? So we have to cancel out these things, BC and AC. We have to cancel out these things, right? So to cancel them out, we can work with this particular triangle and try to cancel them out. So let's work with triangle ABC. So in triangle ABC, what we can see clearly is that the AC squared plus the AB squared, it is clearly equal to, the AC squared plus the BC squared. So AC is the adjacent and BC is the base, will be equal to this hypotenuse, which is AB squared. So clearly think right over here, AC squared with BC squared. In this equation we have AC squared with BC squared, and now we have the AB squared that we needed in that equation. These were irrelevant information, so we can just cancel them out with AB squared in the future. So that's how I logically approach the maths. Okay, now look, let's do some trigonometric ratios. So we can clearly say that in this particular triangle, again, we can say that sine of alpha. What is sine of alpha? The opposite AC divided by the hypotenuse, the AB. So what is AC right now? So from this we can clearly say that AC right now is equal to AB sine alpha. And now what is cos alpha right here? Cos alpha right here is the adjacent BC divided by the hypotenuse AB. So what is the BC right over here? Because BC was irrelevant information that we were holding right over here. So now we can substitute it with AB cos alpha. You see that we didn't draw AB as extra. We drew extra was BC and the extra part was AC. Now both of them are gone from our equations. Now what we can write in our new equation from the 1 and the 2 and the 3, from 1, 2 and 3 we can write that, let's take a different pen. Okay, so now we can write that OA squared, let's put the figure so you can visualize. So OA squared will be equal to OB squared plus so we replace this with AB, so let's take the AB up front, the AB squared plus we have 2 OB and the irrelevant was BC. Now we can exchange BC with this AB cos alpha. Now we just exchange it with our vectors, or we just taking the magnitude, so it's no need to write the vector sign. So r will simply be equal to the OB, which is the p, so we can say p squared, plus the AB, which was clearly the q, so we can say it's the q squared, plus we can say 2OB, which is clearly p, and AB, which is clearly q, and cos alpha. And this was r squared, sorry. And so now r is equal to the familiar formula you all needed, q squared plus q squared plus 2pq cos alpha. Sorry. And that, my guys, is the formula or the parallelogram law that you knew, and it was made clearly very easy for you guys to understand the whole concept of this. And so in the next few classes we will just tackle with some basic problems related to this. Till then, goodbye.